The number of bacteria in a dish obeys the law of exponential growth. Suppose there are initially 1,000 bacteria, and the number doubles every 20 minutes. When will there be 5,000 bacteria? So this is a word problem. We need to introduce some function, introduce some terminology here. So suppose that we set n of t to be the number of bacteria at time t. And an important thing here is that we have to make a decision right now whether we want to measure t in, do we want to measure t in seconds, in minutes, in hours? We're told here 20 minutes. So let's go ahead to say, t is measured in minutes. We could have done this in hours, and then in 1/3 of an hour, the population has doubled. But I think it's easiest just to stick here with minutes here. And our law so the important thing here to remember is that bacteria satisfy an exponential growth law. N of t is equal to n naught e to the RT, where we need to figure out what are, let me highlight here, n naught and r, those are constants that we need to figure out. So what we're going to do is we need to figure out those constants, and then we'll be able to proceed with our problem. Well, let's start by plugging in. First let me copy this. N of t is n naught e to the RT. What happens if we plug in 0? Well, we get n naught e to the r times 0. E to the r times 0 is e to the 0. E to the 0 is 1. This is n naught times 1. This is just n naught. This is the initial population. And if we just go back and reread the problem, suppose there are initially 1,000 bacteria. This shows us that n naught, this is equal to 1,000. So n naught is equal to 1,000. Okay. Part number 2 is we need to figure out, there's two constants here, we need to figure r, and the piece of information that we're going to use is, the piece of information we haven't used yet, the number doubles every 20 minutes. So what does that tell us about n of 20? Well, that's 20 minutes after it's 1,000. It doubles every 20 minutes. So this is 2 times 1,000. So when t is equal to 20, n of 20 is 2,000. Okay, so let's plop that up in here. So from our formula, n of t is n naught e to the RT. 2,000 is equal to n naught, which we know is 1,000, e to the r times t in this case is 20. And so now we have to solve this equation. 2,000 is equal to 1,000 e to the r times 20, 20 times r. We need to solve this for r. Okay, how do we do that? Well, first thing is that let's divide both sides here by 1,000. And so we are left with 2 is equal to e to the 20r. Okay, so how do we do this? How do we get, our variable r we're trying to solve for is in the exponent. So let's take the natural log of both sides. So then that leaves us with the natural log of 2 on the left. On the right, we end up with log of e to some exponent is just that exponent 20r. And so r is equal to not log of 2 divided by 20. By the way, importantly, let me write down a common wrong answer you know, that this is log of 2, all of that over 20, not log of 2 over 20 like that. This is incorrect. Okay, so we've got our answer here for what r is. We figure out what n naught is. So putting all of this together, our equation is now n of t is 1,000 n naught e to the log of 2 divided by 20 times t. So all I did there was took n of t is n naught e to the rt, plopped in 1,000 for n naught, r is log of 2 over 20. Well, let's go back to what was the question actually asking us. When will there be 5,000 bacteria? We want to know, when is this equal to 5,000? And so now we're going to solve the equation for t. How do we do that? Well, let's start off by dividing both sides by 1,000. If we divide both sides by 1,000, we are left with, this is 5. And this is e to the natural log of 2, all of that over 20 times t. And then once again, let's take natural log of both sides here to be able to bring down the exponent. So on the left here, this just becomes natural log of 2 over 20, all of that times t is equal to natural log of 5. And to finish off this problem, let us divide by natural log of 2 over 20, and we are left with t is natural log of 5 times 20 over natural log of 2. Which maybe it looks a little bit nicer. I'm just going to make a cosmetic change here. Log of 5 over log of 2, all of that times 20. So this is our final answer. This is our final answer, and we should leave it, let's just leave it unsimplified, including the logs. You want to get an estimate to estimate roughly how big it is. You can plop into a calculator, but for quiz and test purposes, you want to leave it like this. Let me just finish this off by observing here another incorrect way to do this. Some people might be tempted to simplify log of 5 over log of 2 as log of 5 halves. And that's, again, an incorrect simplification. That, you know, our logarithm rules do not work like that.